One of the principles behind the design of Unix is that everything is represented as a file. Of course, something like main.c or an executable like a.out, we know that's represented as a file. But also the whole disk that you might use to save those files, the raw bytes of those disks are available, if you have sufficient privilege, from the /dev/sda1 device, or depends on what kind of disk you have, but /dev sda1 is a common option. Similarly, a terminal that you might connect to your machine, available as screen 1 or screen 2 or so on, that can be represented. The raw interaction with that terminal is /dev tty2. As another kind of example, proc CPU info. That looks like a file on the file system, but it's not actually a file on the file system. When you cat proc, let's use more proc CPU info, then it looks like you're looking at a file. It tells us that I have a processor with the first core is a Core i5, and then there's a second core. This is actually a virtual machine, so it's not reflecting all of my cores since that's the way I've configured it. And in fact, if I shut down the virtual machine, change the virtual machine configuration, and restart, then the content there will change. It's not a file on the file system. It's a way that the kernel can communicate to you and tell you what it saw about the CPU. In fact, any kind of communication between programs, the Unix way of doing that is representing it as a file, as this notion of bytes that you read and write, including the input and output that a program has. The name for a handle to a particular file, whether it's named or not, is a file descriptor. It's represented in the type system as just an integer. So everywhere you see file descriptors are just going to be ints, but that's a handle to a particular file, named or not, for communicating.